All right, so the first two videos have been sent to you, but they've been sent to you individually, so you'll need to go back at some point and watch, review 1 through 75, part 1. You'll have to find another place, find review 1 through 75, part 2, and then this will be review 1 through 75, part 3. I want to pick it up here, looking at question 23. Determine if the events are independent or dependent. You draw a deck, draw a 10 from a deck of cards. You replace it, then you draw 2 from the deck. Those two events, are they dependent or independent? Okay, so I've got one that says independent, one that says dependent. What's your question? What do you need? Oh, are you done? Okay. Okay. So the answer is that they are independent. And the reason that they're independent is because the total is left unchanged. And the key word in here is what? Can anybody tell me what the key word in that sentence that separates dependence from independence? What? Replace. The word replace. Okay, because we put it back. Okay? What's that? This is question number 23, and it is independent. Because if it was dependent, that means that I took the card out of the deck and kept it, right? That's going to change the probability for the next person. What happened whenever I pulled the card, right? If I pulled the second card, is dependent upon what happened with the first guy, right? Because the card was put back, now I have two independent probabilities, okay, that could be exactly the same, okay? So we are going to say independent, okay? Again, this is another good reason to go back and not just watch the video, but listen to it, because there's a lot being said there that is not drawn on the screen. Okay, number 24, it says divide 12x to the fourth minus 18x cubed plus 36x squared by 6x cubed. Use polynomial long division. All right, do you guys have this? I'm going to go to a page, right, where I can work all this out so it can be shown. All right, so I'm going to require you guys to tell me what those numbers were. Okay, I want to be able to divide. Give me the whole deal that I'm dividing. 12x to the fourth minus 18x cubed. Okay, but we're dividing by 6x what? So all of this has to go in there. Okay, so this one's not as bad as some of them that we could do, because we're going to see that 6 is going to fit into these things fairly easily, right? 6 is going to go into 12 2 times, and x is going to go in there once, right? All right, I'm going to bring that down here. That's going to give me 12x to the fourth. I could subtract that. I'm going to get 0. So what I'm going to do is I'm going to bring down the negative 18x cubed. All right. Now, what would I have to multiply 6 by to get it into negative 18? Negative 3. And it's already x cubed, right? So I actually don't need an x there. That's going to make it negative 18x cubed. Whenever I subtract, those things are going to cancel. I'm going to bring down 36x squared. Now, part of this is easy. The other part is kind of tricky for folks, right? What will it take to get 6 to go into 36? 6. Now, there's two ways of kind of doing this. How am I going to get x cubed into x squared? What would that be? Okay, well, up to this point, we've done x cubed times x is x to the fourth, right? So let's think about this. X cubed times x to the something equals x squared. Let's think about that for a second. These things are multiplying by each other, right? Okay, what happens to the exponents whenever I multiply variables? What do I have to do to them? Add. So let's look at it this way then. 3 plus, we'll say x equals 2. right? 3 plus what equals 2? Well, how would I solve for x here? Subtract 3, right? And I think Dahlia said it, -1, right? So this would normally be 6x to the negative first. In fact, I would probably accept that if this was one that you were writing out. But they are going to change this so that my answer comes out as 2x minus 3 plus 6 over x. Because in order to get that x with a positive exponent, I drop it below the division bar. Okay, and whenever I do that, the 6 stays on top, the x moves to the bottom. Okay? So this would be the kind of work that I would want to see on a question like this. Does that make sense? Now, you don't necessarily have to show me all of this stuff over here, right? But I should be able to see this through here and then hopefully get an understanding of why we're getting that. Okay? We're all right? Cool. Let's get back to this. All right, number 25 says find the value of a, give the answer to the nearest tenth. All right, and I'm going to assume that, was I right on number 24? Did anybody go down to the answer key and check that out? It was right. All right, number 25, find the value of a, give the answer to the nearest tenth. Okay, how might I go about finding that? Anybody know? I think we're making this way more difficult than it needs to be. Pythagorean theorem, right? A squared plus b squared equals c squared. Now tell me, how am I going to use this information? Plug in 14 for c. Okay, so 14 or just 14 squared? 14 squared. Okay, what about on the left-hand side? 10 squared. Okay, and that's fine. What's 10 squared? 100 plus a squared. I don't know. I'm thinking like 228, but I don't know. That's probably not right. What's that? 196. I was way off. 196. All right, what do we want to do with that 100? Subtract it. So a squared equals 96. And I want just square root. It says to the nearest tenth, so that tells me, do I want a decimal or do I want a simplified radical? Decimal. So what does a equal to one decimal point? 9.8. Okay, is that at the answer at the bottom? 9.8. Very good. All right, we get so used to seeing, as we get up to this point, we're thinking, oh man, I'm going to have to use like law of sines or law of cosines for this, right? No. Right, solve it the easiest way that we have available to us here. It's just a simple Pythagorean theorem question. All right, 26. Graph the system of linear inequalities. I'm going to go back. You guys hopefully have that. I'm going to go to this page over here and work this question out. It was, somebody give me those two equations. Y greater than? Okay, and the other one?
Y is greater than or equal to -3x
minus 5. -3x minus 5?
Yeah.
Okay. Is this right? Okay. Okay. So let's look at this. All right, the thing that we're going to start with, let's go ahead. I'm going to get some tick marks. 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, just to start with. All right, where do I want to begin? What's the first thing I start to graph? The y-intercept, right? So at 3, and what's the next thing I want to do from there? What do I want to graph? The slope. So what am I going to do from my y-intercept? Over -3? Down 3 to the right or left? Okay, so I'm glad we're covering this because this might explain why we get some things wrong. All right, so -3x, okay, as a slope is over 1, right? So the negative always goes with the numerator, right? So I'm going down 3. That's the negative. The 1 is positive, right? So I'm there. Then I'm going to go 1, 2, over 1. 1, 2, 3 down, over 1. Okay? And I can do that same 1, 2, 3, back 1, right? Okay, so is this a dotted line or a solid line that I would graph? Dotted. Okay, so that's kind of, okay, something like that. It's not great. Now I want to be able to shade it, right? Because we're saying y is greater than. And that can sometimes be confusing. What would we use as a test plot to check? You know, do we remember test plots? You can use 0, 0, because notice that 0, 0 is not on the line, so that's helpful. So let's check and see if I wanted to shade 0, I would want 0 to be part of the solution. Is 0 greater than 3? No, so it's not part of the solution, therefore I'm going to shade this side. Does that make sense? Okay, now let's graph the other one. Okay, let's see, we'll pick something else here. What's the first thing you want to graph? Oh, -5. 1, 2, 3, 4, 5. Okay, and up 3 and to the left. 1, 2, 3. Because we don't have enough room to go to the right, correct? 1, 2, 3. And we're about there. 1, 2, 3. Maybe about there. Something like that. Okay, we could go 1, 2, 3, and probably. All right. Now, is this a solid line or a dotted line? Solid. Solid. Okay, not great, but you get the general point. Okay, it's tough whenever your hand is a shadow in the way of drawing. Okay, now let's check this. We're going to see where we want to shade. Okay, could we try 0, 0 again? Okay, is 0 greater than or equal to -5? Yeah. Okay, so what we're going to do is we're going to shade this way. All right, so what you should see is your really dark shaded region is going to be over here because both of them shade that way. And really lightly, you're going to get shading in here. Does that make sense? So if you look at a series of graphs, you're going to see 2 parallel lines because you'll notice that they have the same slope, but they have different y-intercepts. So you're going to see 2 parallel lines, and to the left, you're going to see no shading. In between them, real light, and to the right of that second line, you're going to see it very darkly shaded. Does that make sense? Okay. All right, let's get back over here. Number 27, find an equation for the inverse. What can I substitute f of x out with? Y? Good. All right, so I can substitute that out and say y equals, and I could even rewrite that as 1/5 x plus 4, right? If I want to find the inverse, what's my rules for finding the inverse? I have 2 rules, or a series of events I need to go through. Let me remember what the first one is. Switch x and y, okay? We'll go ahead and do that. We've got x equals, 1/5 y plus 4. What's the second step? Solve for y. Solve for y. Okay, so let's go ahead and do that. What's the first thing to do in solving the red equation? Subtract what? 4. Okay, so that's going to give me x minus 4 equals, and we could call this still y over 5 if we wanted to. Okay, if that helps. All right, what would you do there to solve for y? Multiply by 5. Now, what do we mean by when we say multiply by 5? Do we mean we're going to get 5x minus 4? What are we going to do? We're going to distribute. All right, so I'm going to get 5x minus 20 equals y, or y equals 5x minus 20. It probably looks a little bit better like that. What's the answer at the bottom?
5.
What, just 5?
No, 5x
minus 4? Did I mess something up? It's question number 27.
Yeah. It has it down as before distributed. Yeah. So it's just
Oh, okay. So what it's showing then is y equals 5 times x minus 4. Is that right?
Yeah.
Okay. I like 5x minus 20 better. What do I know? Okay. Let's see. Number 28. Find the measure of the reference angle for 141 degrees. Okay. 141 degrees. So we got our guy right here. We have our initial side. 141 degrees. Which direction am I heading? Am I going clockwise or counterclockwise? Counter. Okay. 141 degrees. There's 90. Here's 180. Which quadrant is my terminal side going to be in? 1, 2, 1, 2, 3, or 4. So 2. 2. It's going to look like this. All right. Is my reference angle in the or in the red zone? Always, always, always in the red zone. It will always be the angle between the terminal side and the x-axis. Always. If you're ever finding the angle between my blue and my y-axis, you've done it wrong. Okay. So what we want to know is what are the number of degrees left, all right? What's between my blue and my x-axis? Okay, well, if it was 141 degrees, how am I going to find that out? All right, so 180 minus 141 should be 39 degrees. Is that right? Okay, 39 degrees. Is my reference angle, is it ever going to be a negative number?
No.
Even if I'm going in the clockwise negative degree direction? It's never going to be negative. Okay? Even if they give you negative degrees, your reference angle will be positive. Okay? All right, number 29. Solve by completing the square. I don't know if you guys remember how to complete the square or not. So I'm going to try to help you out here. X squared minus 12x plus 36 equals 24. In completing the square, what I want to do is I'm going to get all of this over to the right-hand side first. All right, so I'm actually going to subtract 36. X squared minus 12x. What do I get over there? Negative 12. Okay, what I'm going to do is I'm going to take negative 12, divide it by 2, and square it. Huh? Because you take this number, you divide it by 2, and you square it. Okay? Let's see, what's negative 12 divided by 2? Negative 6. Negative 6 squared. I'm not sure if this is what, because you're going to wind up with 36 again. Don't you subtract? You're asking if you subtract 24. Well, we can sure do that if you want to try it. Okay, she's saying subtract 24. Okay, so she's getting x squared minus 12x, what, plus 12? Okay. Now what? I think what you'd actually do from here is subtract the 12 back over. But then there again, you're still winding up with where you were last at. So I think that the question is, because it says solve by completing the square, I think it's asking you to do the wrong thing. I think what you want to do is you want to subtract 24. So you're getting x squared minus 12x plus 12. Right? Now, we know we can't solve that by factoring, but we can solve this by quadratic, which means we would take 12 plus or minus the square root of negative 12 squared minus 4 times 1 times 12, all over 2 times 1. Okay? So as I move it over here, we're getting 12 plus or minus. Negative 12 squared is 144. It's going to end up being 144 minus 48. Somebody find that number for me.
44 minus 48, 96.
96, right? 96 over 2. Square root of 96, I don't know if that's a perfect square or not. No. Okay, so we would end up taking 96 and simplifying that down. That would be 2 and, is that 48?
Yeah.
2 and 48, 2 and 24, 2 and 12, 2 and 6, 2 and 3. Pairs of 2's. So what we're getting there is 12 plus or minus 4 radical 6 over 2. Simplify that down, you're going to end up getting 6 plus or minus 2 radical 3. What was the answer?
6 plus or minus 2 radical 6.
Oh, okay, that was my mistake. 2 radical 6, because you don't change that. You don't divide that by 2. Okay, so that, you basically need to change it into the quadratic equation and then plug your quadratic equation into the quadratic formula. Okay? Sorry about that. Well, I mean, it says solve by completing the square, and you don't. Not really, not for that. Okay, 30. Write solutions in terms of I. Okay? X squared plus 2x plus 10. Solutions in terms of I. This is going to come back to the quadratic formula again, because our answer will be in terms of I. So this would be negative 2 plus or minus the square root of 2 squared minus 4 times 1 times 10, all over 2 times 1. Negative 2 plus or minus over 2. Let's see, that's going to be 4 minus 40, so it'd be negative 36. All right, how do we rewrite the square root of negative 36? 6i. So we got negative 2 plus or minus 6i divided by 2. Let's simplify that down. What's negative 2 divided by 2? Negative 1 plus or minus, what's 6 divided by 2? Plus or minus 3i. What's the answer at the bottom?
Actually, negative 1 plus 3i or negative 1 minus 3i.
Which is this, right? Okay. What time are we out of here? You guys probably know. 23. I got time for another. All right, identify all the real roots. Okay. What do you think? With 1 minute? We want to stop there? Okay.